and welcome to our new video where we discuss about partial differentiation. You already know about the differentiation. Now what is the partial differentiation? In simple differentiation we have y equal to fx. Y is one dependent variable on x. So x is independent variable. So when we talk about the partial differentiation, it means we have function of more than one independent variable. Z is function of x comma y. So there are two independent variable and z is depend on x and y both. So in this case we cannot derivate it directly. We call this is partial differentiation. When we have to find out del z by del x also and del z by del y. At the place of d we replace in partial differentiation notation is del. Second one, both are independent variable. When we derivate this with respect to x, our other derivative y is constant. Similarly, when we derivate this function with respect to y, our derivative x is constant. For example, just very simple, z square is equal to x square y plus 2xy square. So if we find del z by del x, differentiate this with respect to x. Differentiation of x square is 2x. Y is constant, putting like that. Plus differentiation of 2x is only 2. So 2y square treating as a constant, put just like. Similarly del z upon del y. Del z upon del y is same. Differentiate this with respect to y. So derivation of y is 1. So x square treating as constant plus 2x is constant, y square, derivative of y square is 2 of y. So these are called partial derivative with respect to x and y of given function u. Clear? So here in partial differentiation we have many independent variable, 2, 3, 4 up to n. So which with the help of this and this, whatever we have to derivate, that is only the function, all other treating as constant. When we have to derivate this, then all other than this are constant. So this is called partial differentiation. One more thing, when you learn about the partial differentiation, if any function of fx and y, if z is any function, then del z by del x, del z by del y are the first order derivative of this given function. Then del 2z by del x, del y, del 2z by del x square, del 2z by del y square. Or we can say this is del 2z by del y del x. These are 3 second order derivatives. So this first order derivative are known as p and q. This is known as r, this is s and this is t. This notation you can see in the partial differential equation. They given the differential equation in notation of PQRST. So you have to know what is P. P is del 2z by del x del y. What is R? Sorry. What is P? P is del z by del x. What is T? T is second order derivative with respect to y. So these are the standard notation you can see in any book. First order derivative of x and y is P and Q. Second order derivative are R, S and T. Now I will show you some example how to find out the partial differentiation with respect to given data, with the help of discussing some examples. For example, if we have a function z is equal to x to the power y plus y to the power x. In this case, you and there show that prove that del 2z upon del x del y is equal to del 2z upon del y del z. Del x means it is symmetric. So in this case, what is the our process? First step, we are writing this function with exponential and logarithmic term. So this is e to the power y log x plus this is e to the power x log of y. Clear? Now with this you can easily differentiate. When we del z by del x, differentiate this with respect to x. Differentiate, so first exponential power, so e to the power x, derivative is e to the power x. Now derivative of log x is 1 by x, so we write 1 by x. Clear? Plus differentiation of this is x log y and derivative of x is 1 only. Clear? So del z by del x, again del z by del y you can find out. Next is the second order. Second order means one time you differentiate this with respect to y. So you will get this. Similarly, one time you will differentiate this with respect to x. So you will get this. Both have same solution. So this can be proved. So in many cases, one more example I can show you. There are many different types of question in partial differentiation. If your concept is clear, it is very easy. If u is equal to x square plus y square upon x plus y, then prove that del u by del x minus del u by del y whole square is equal to 4. 1 minus del u by del x minus del u by del y. Clear? So in this case, u is equal to this. So what first we remove this denominator, otherwise with the denominator u by v, so first derivative plus y is equal to x square plus y square, means xy comes up. Now we differentiate like a equation. How we differentiate? I can show you. First partial equation 1, partially differentiate with respect to x. When with respect to x, this is u is also function of x, this is also. So when we differentiate this gives del u by del x into x plus y plus u as it is d by dx of x is 1 equal to 2x. Y goes 0 because it is constant. So this equation is del u by del x into x plus y plus u equal to 2x. More simplify the value of del u by del x. So del u by del x is equal to 2x minus u. U means our this function upon x plus y. Clear? This is our equation number 2. Similarly, equation 1, differentiate with respect to y. When we differentiate this with respect to y, our del u by del y comes 2y minus u upon x plus y. This is our equation number 3. Now what they want? Del u by del x minus, if we subtract y upon x plus y. So when you whole squaring, it is also whole squaring. Same, when you do this side, that also gives this equation. So it's also one easy example for partial differentiation. Now we go for another example. Question is, if u is equal to log of x cube plus y cube plus z cube minus 3 of x, y and z. So what here we prove that del by del x plus del by del y plus del by del z whole square of u is equal to minus 9 upon x plus y plus z of whole square. So what is this? First we see this. This means del by del x plus del by del y plus del by del z into del by del x plus del by del y plus del by del z of u. Clear? Whole square means 2 times. Now u come inside. So this is del u. So means del u by del x plus del u by del y plus del u by del z. First we have to find out this. Then this term with del by del x means this terms differentiate with respect to x gives this term. This term differentiate partially with respect to y gives this term. This term differentiate partially with respect to this gives this. Clear? Function is this. Now we go for our new function. For example, means if I say this is our v, then what is this meaning? Del v by del x plus del v by del y plus del v by del z gives the required solution. Clear? Means this is not del u by del x, you have to find out and you take the square. That is not same meaning of this. Meaning of this term is this. If we consider this term v, then this. Clear? Now we go further, that if you go further, you just find out the derivative and just you simplify, do this. You can easily get. Next, I will give one example when given function in terms of r and r is given in terms of x and y. For example, if u is equal to function of r, clear, and means u is not directly function of x, y, u is function of r, and here given r square is equal to x square plus y square plus z square, means r is function of x, y and z. In this case, we have to prove that del 2u by del x square plus del 2u by del y square plus del 2u by del z square equal to f double dash r, means second order derivative of r, plus 2 by r of f dash r. This is very good example for partial differential, how we can derive. Okay. So now we see u is equal to fr, means if we have to find out del u by del x, means we can write del u by del r and del r by del x. Clear? Del u by del x is del u by del r del r, because with this equation we can find out the del r by del x. With this equation, what is del r by del x? 2r del r by del x is equal to 2x. So del r by del x is x by r. Clear? So del u by del x is what? This is x by r, del u by del r. Now differentiate this when del u by del r is equal to del by del r of fr. So we can write this f dash r. Clear? So this terms is x by r f dash r. Clear? Similarly, this is symmetrical. Similarly, del r by del y is y by r, del r by del z is z by r. So del u by del x, similarly we can find del u by del y is del u by del r by del y. That gives y by r, f dash r. Third one gives z by r, f dash r. Clear? Next we have to find out its second order derivative. Means we have to one more time del by del x. Means we have to differentiate this function del by del x. See here, we have to differentiate this del by del x of this. Same, we can use this as u and this as v. So u by v square means denominator gives r square. This is our given function. Derivative of this, again we have to apply formula u into v. So when they differentiate v as it is, r as it is, now differentiate this x gives 1 into f dash r plus x as it is del by del x of f dash r. Del by del x of f dash r. Clear? So del by del x, how we find out? Del by del r by del x. So del by del r of this is f double dash and del r by del x is x by r. Clear? Next, minus this x f dash r as it is into derivative of this with respect to x. So this is 2r del r by del x. Clear? So you have to just concentrate what is this. This is r square, r is outside, f dash r plus x, del by del x of f r is del by del r of f dash r into del r by del x. See, this and this del r cancel, this is del by. So del r by del x is x by r. So this is f double dash r, this is x by r. I can rewrite this term again, x into f double dash r into x by r. Clear? Minus of x f dash r as it is here, 2r del r by del x. Del r by x, del x is x by r. Clear? Again, this term we have to del to u by del x square. You have to simplify it again. So what is this term? R f dash r minus plus x square f double dash r upon r. Okay, upon r. If we can take LCM, so there comes 1r and their denominators have r. So this r and this r cancel. Minus x and x square, r cancel. 2 is also there. So 2x square f dash r. Clear? So this is what? R f dash r plus x square f double dash r minus 2x square f dash r. Again we collect the data of f dash r. So this gives r minus 2x square of f dash r plus x square f double dash r upon r square. Clear? Now our del to u by del x square is f double dash r x square by r square, and this is f dash r by r, and this is x square. Again we rewrite one more x square. Similarly you have to find out del to u by del y square, del to u by del z square. If you add all these three terms, you will definitely get the right hand side. So that's all for partial differentiation. You can try more problems on partial differentiation, you can see that how to solve these variables with different types of substitution. Sometimes we can make the substitution also. Thank you. Bye.